In this module, we're going to measure light with the TSL2561 luminosity sensor. This is a sensor that measures the amount of light that's shining on it. It's good for measuring how much light is in a room. We are going to wire up a TSL2561. We're going to set up I2C communication on the Pi, and then we're going to use a Python script to read and display values. The TSL2561 is a lux sensor. That means it measures the amount of light that's shining on it. It approximates human eye response, which means it tries to measure how much light a human would actually see. Now you can change the settings of this device to measure things like IR that are outside of the range of human sight as well. It measures from 0.1 to 40,000 lux, and it works at 2.7 to 3.6 volts. As you can see here, we've wired this up similar to how we wired up another I2C device in a previous module, the BMP180. In this case, I have different colored wires, but the wiring itself is the same. I have a gray wire for 3.3 volts in, going to pin 1. I have a purple SDA wire going into pin 3. The white SCL wire is going to pin 5, and a black ground is going to pin 6. On the device itself, you can see where each of these wires go. The pins on the 2561 are labeled appropriately, and in this case we're going to be using the volts in, ground, SDA, and SCL pins, as shown. For the physical wiring on the Pi, I've wired each pin from the TSL2561 directly to the GPIO pins that we've shown in the diagram. So this is the only physical setup you'll need for this project. Okay, and now I'm connected to my Raspberry Pi through SSH, and I'm going to need to install some dependencies for this project. Here I've typed in sudo apt-get install git build-essential python-dev python-smbus and I2C tools. This is what you'll need to install on your Pi to do this project, and as you can see, I already have these tools installed. So now we're going to go to sudo raspi-config. And on this screen, we want to go down to number 9, which is Advanced Options, and then scroll down to A7, which is I2C, and press Enter. And here it will ask, would you like the ARM I2C interface to be enabled? Select Yes. And now it shows that it'll be enabled after a reboot. So press Enter. Now here it asks if you'd like to load the I2C kernel module by default. And here we want to select Yes. And then click Enter. And now we'll select Finish. It asks if we'd like to reboot, select Yes. And now we've rebooted and we're back at our prompt. And the next thing we want to type in is sudo nano etc modules. And we will open this file up. Now in modules, we want to put the following 2 lines. These 2 modules we want to load into the kernel at boot. So let's save and exit. Next, we're going to edit our boot config. We do that by typing in sudo nano /boot/config.txt. Now here, all the way at the bottom, we want to put in the following 2 lines to enable I2C. And then we'll save and exit. And now let's reboot the Pi. And now we've rebooted and we're back to the SSH prompt. Now what we're going to want to do is check to make sure our wiring and configuration is correct. And this is how we'll do it. I'm using a Raspberry Pi 2 for this demonstration. So for the Raspberry Pi 2, you type in sudo I2C detect -y and then a 1. If you're using a Raspberry Pi 1, then you just change that 1 to a 0. You see the number 39 there? That shows that our device is connected and ready to go. If you don't see a number there, check your physical wiring and check the setup instructions that we did earlier. You should see a number. It's somewhere in that matrix and it should be some type of number. In our case, it's 39. The TSL2561 is a bit of a complicated device, and people have done a lot of the heavy lifting with the software for this. Now what we're going to do is use wget to download a couple files from GitHub repos in RAW mode. Now this brings the file directly down to your Pi. Remember to manually review the file before bringing it down for security reasons. And here's the command we'll use. and press enter. As you can see, this file is downloaded successfully. And that's from the Adafruit I2C library. The next thing we're going to download is something that's written by a fellow named Sean Beckhofer. I'm hoping that I pronounced that correctly. And we're downloading this from his personal repo. And now we have the two files that we need. And now we'll type in sudo python TSL2561.py. And if everything's wired up and we're configured correctly, we should see some readings. And as you can see, I have a reading here of 76.10824. So what I'm going to do is shine a little more light on it and see if it shows additional light. And now we're going to shine a little more light on it. And as you can see, it shows a significant higher reading. So let's go ahead and block out some light. And now we should show a lower reading. And as you can see, it shows a much lower reading. And that's all there is to using this device. Now you can adjust the gain on this part if you'd like, and I would highly suggest tuning it to your environment. So I'll show you where to do that. You type in sudo nano tsl2561.py. As you can see, we have a few print statements here at the bottom of the file, and it says lux, high gain, low gain, and auto gain. And as you can see, the only thing you need to do to change those values is to set a parameter to the readLux method. So if we uncomment this, this will display the lux with the auto gain, and so forth. So you can adjust this to your environment and adjust it to the amount of times you're sampling it and things like that, and just kind of play around with it until you get it exactly where you want it. In this module, we wired up a TSL2561 and we set up I2C communication on the Pi. And then we used a Python script to read and display values. I also showed you how to adjust the gain, and we did a small demonstration shining light and taking light away to show the lux sensor at work. Now this lux sensor could be used for various IoT projects, such as weather projects that are measuring sunlight, humidors or wine cellars, or rooms that store documents or other sensitive items. Or you can use it as part of an alarm system. You could even use it to see if there's light in a particular room and build a system to remind your kids to turn off the light when they leave the room. The possibilities are endless. And now, on to our next module.